Have you ever thought of going back in time to the past to undo a wrong? Or to make a different decision, or even completely change the course of history? Even if you want to, is it even possible to travel through time? Maybe it is. Time as physicists do, that is looking at time as a fourth dimension. This dimension is another kind of length, a length in time. While a human may survive for 80 years, the stones at Stonehenge have stood around for thousands of years, and the solar system will last for billions of years. Everything has a length in time as well as space. Traveling in time means traveling through this fourth dimension. To understand this, let's perform an activity, like walking on a straight road, and you're traveling in one dimension. Turn right or left and you add the second dimension. Climb up a wedge and that adds height, so that's traveling in all three dimensions. But how do we travel in time? Time travel movies often feature a vast energy-hungry machine. The machine creates a path through the fourth dimension, a tunnel through time. The concept may be far-fetched, and the reality may be very different from this, but the idea itself is not so crazy. Physicists have been thinking about tunnels in time too, but they come at it from a different angle. Wormholes. A wormhole is a theoretical tunnel or shortcut, predicted by Einstein's theory of relativity, that links two places in space-time. They remain only hypothetical, as obviously nobody has ever seen one. The idea of wormhole comes from the fact that nothing is perfectly flat or solid. If you look closely enough at anything, you'll find holes and wrinkles in it. Now this is true in the first three dimensions, so it's also true for the fourth dimension, that is time. There are tiny crevices, wrinkles and voids in time. Down at the smallest of scales, even smaller than atoms, we get to a place called the quantum foam. This is where wormholes exist. Unfortunately, these real-life time tunnels are way too small for a human to pass through. But here's where the time machines comes into picture. Some scientists think it may be possible to capture a wormhole, and enlarge it many trillions of times to make it big enough for a human, or even a spaceship to enter. A time tunnel or wormhole could do even more than take us to other planets. If both ends were in the same place, and separated by time instead of distance, a ship could fly in and come out still near Earth, but in the distant past. There is a big problem with wormholes, which is explained by using paradoxes. The most famous one related to wormholes is called the grandfather paradox. Person who travels to the past and kills their own grandfather, preventing the existence of their father or mother, and therefore their own existence. Professor Stephen Hawking gave a new, simpler version, which he called the mad scientist paradox. A scientist was determined to create a paradox. He somehow built a wormhole, a time tunnel that stretches just 1 minute into the past. And now our scientist uses the wormhole to shoot his earlier self, because, you know, he's mad. Now the scientist is dead. So who fired the shot? It's a paradox. This kind of time machine would violate a fundamental rule, that cause happen before effect, and never the other way around. In the end, a wormhole like this one can't exist. And the reason for that is feedback. If you've ever been to a rock gig, you'll probably recognize the screeching noise. It's feedback. Sound enters the microphone, it's made louder by the amplifier, and comes out at the speakers. But if too much of the sound comes from the speakers, it goes back into the mic and goes around and around in a loop, getting louder each time. If no one stops it, feedback can destroy the sound system. The same thing will happen with a wormhole due to radiation. As soon as the wormhole expands, natural radiation will enter it, and end up in a loop. The feedback will become so strong, that it will destroy the wormhole. That means traveling back in time is near to impossible. But this doesn't make all time travel impossible, like time travel to the future. Time is just like a river, also it flows at different speeds in different places, and that is the key to traveling into the future. This idea was first proposed by Albert Einstein. He realized that there should be places where time slows down, and others where time speeds up, and the proof is right above our heads. The Global Positioning System, a network of satellites, is in orbit around Earth. These satellites make satellite navigation possible, but they also reveal that time runs faster in space than it does down on Earth. Inside each spacecraft is a very precise clock. But despite being so accurate, they all gain around a third of a billionth of a second every day. The system has to correct itself. The problem doesn't lie with the clocks. They run fast because time itself runs faster in space than it does down below. Einstein realized that matter drags on time and slows it down like the slow part of a river. The heavier the object, the more it drags on time. Right in the center of the Milky Way, 26,000 light-years from us, lies the heaviest object in the galaxy. It is a supermassive black hole containing the mass of 4 million suns crushed down into a single point by its own gravity. A black hole like this one has a dramatic effect on time, slowing it down far more than anything else in the galaxy. That makes it a natural time machine. A spaceship might be able to take advantage of this phenomenon, by orbiting it. Close to this massive object, time would be slowed down such that, if they circled the black hole for 5 of their years, 10 years would pass elsewhere. But it's pretty dangerous. It's a long way away and it doesn't even take us very far into the future. Fortunately, there is another way to travel in time. And this represents our last and best hope of building a real time machine. Cosmic speed limit, 186,000 miles per second, also known as the speed of light. Nothing can exceed that speed. Believe it or not, traveling at near the speed of light transports you to the future. To explain why, imagine a track that goes right around Earth, a track for a super-fast train. No matter how much power the train has, it can never quite reach the speed of light. Instead, let's say it gets really close, just shy of that ultimate speed. Now something extraordinary happens. Time starts flowing slowly on board relative to the rest of the world, just like near the black hole. This happens to protect the speed limit, and it's not hard to see why. Time will always slow down just enough to protect the speed limit. And from that fact comes the possibility of traveling many years into the future. For a week passed inside the train, a century would have passed on Earth. Of course, building a train that could reach such a speed is quite impossible. But we have built something very like the train, at the world's largest particle accelerator at CERN, in Geneva, Switzerland. Deep underground, in a circular tunnel 16 miles long, is a stream of trillions of tiny particles. When the power is turned on, they accelerate from 0 to 60,000 miles per hour in a fraction of a second. Increase the power and the particles go faster and faster, until they're whizzing around the tunnel 11,000 times a second, which is almost the speed of light. But just like the train, they can only get to 99.99% of the limit. When that happens, they too start to travel in time. We know this because of some extremely short-lived particles, called pi mesons. Ordinarily, they disintegrate after just 25 billionths of a second. But when they are to near light speed, they last 30 times longer. It really is that simple. If we want to travel into the future, we just need to go fast. Really fast. And the only way we're ever likely to do that is by going into space. The fastest manned vehicle in history was Apollo 10. It reached 25,000 miles per hour. But to travel in time, we'll have to go more than 2,000 times faster. And to do that we'd need a much bigger ship, a truly enormous machine, which will take us to the future. Hope you liked the video. If you do, please like, share and subscribe. Also let us know what do you think about this video in the comment section below. If you have any advice and suggestions for future episodes, please type it in, we will love to do it. Please click on the notification button so that you won't miss any updates from our channel. Also like our Facebook page. And for business inquiries, mail us on our Gmail ID. Thank you for watching. See you soon. Till then, keep watching and take care.